Hi students, good morning. Welcome to our video classes. In the previous class we have learnt about properties of acids. Today we are going to learn properties of bases. Simply, what are bases? We are familiar with some substances like washing soda, cooking soda, lime water. What are these? All these are metal oxides or metal hydroxides or metal carbonates or metal bicarbonates. If we observe the taste of these substances, all these are bitter in taste, and not only these are bitter in taste. If we apply these substances to the fingertips of our hands, that are slippery, just like they behave as slope. How do we feel when we touch a soap? In the same way, we feel soapy when we touch these substances. These are the which substances? These are nothing but bases. That means simply the substances which are better in taste and soapy to touch, simply that are called as bases. We observe the solutions of some substances like cooking soda, washing soda, caustic soda. Cooking soda means that is sodium bicarbonate. Washing soda means sodium carbonate. And lime water means calcium hydroxide. Caustic soda means sodium hydroxide. All these are better in taste and soapy to touch. That's why all these substances are bases. And already we have learnt neutralization reaction. When a base is added to acid, then what happens? That acidic nature is neutralized by the substance which is added to it, that is called as base. That's why these bases are the substances which neutralize the acids. In this way also we define these bases. What are the bases? Bases are the substances which neutralize acids. That's why simply bases are the chemicals opposite to acids. Okay, then metals. What are metals which are electropositive in nature? Sodium, potassium, calcium, magnesium, zinc. All these are examples for metals. We know when metals reacts with oxygen, metallic oxides are formed. When metal reacts with metal carbonates, metal hydroxides, metal hydrogen carbonates. That means metal oxides, metal hydroxides, metal carbonates, metal bicarbonates. All these are basic in nature. That's why all these are the examples for bases. Next, alkalis. Simply, what are alkalis? In this diagram, see, what are given? Baking soda is given. Baking soda means that is sodium bicarbonate. Metal, it is related to metal part. That's why it is a base. And ammonia. Even ammonia is not a metal, but this ammonium hydroxide is a base. Then alkalis. What are alkalis? Most of the bases do not dissolve in water. Only some bases dissolve in water. The base which dissolve in water, that is called as an alkali. That means when a base is added to water, any reaction is not happened between this base and water. Just this base dissolves in water and a solution is formed. Then that solution is simply called as aqueous solution of base, or a solution which is formed by the base when it dissolves in water. That solution is called as an alkali. That means simply, what is alkali? Alkali is a base which dissolves in water. That means all alkalis are bases, but all bases are not alkalis. Why? Most of the bases do not dissolve in water. Okay, in this chapter we are going to study about alkalis. Only water soluble bases, that are called as alkalis. That means in this concept, whenever we mention an alkali, that means simply it is a base which dissolves in water. Then these basic properties are due to what? That means somewhat is common for all the bases. A scientist named Arrhenius defined what are acids. Acids are the substances which produce H plus ions in water. That means it is the presence of H plus ions which impacts the acidic nature to that substance. That means what is common to all the acids? H plus ions. In the same manner, somewhat impacts to a substance its basic nature. Somewhat impacts its basic nature for the substance. What impacts this basic nature to the substance? Let us observe with an activity. Take a base simply. Dissolve in it water. That means already we know how to dilute an acids and how to dilute a base. Simply take water in required proportion, and what is added to it? A base is added. Whenever we add the base to the water, is the water and base reacted with each other? No, that are not reacted with each other. Simply in the presence of water, this base splits into its respective ions, positive ions and negative ions. For example, if sodium hydroxide is added to distilled water, then the sodium hydroxide splits into Na plus ions in water and OH minus ions in water. And in the same manner, if we add potassium hydroxide, again this potassium hydroxide splits into potassium ions, positive ions, and hydroxide ions, negative ions. That means in the presence of water, when a base splits, what are produced? OH minus ions are produced. That means these OH minus ions are common to all the bases. How the H plus ions are common to all the acids, in the same manner these OH minus ions are common to all the bases. That's why we define these bases in another way. How bases are the substances which produce OH minus ions in water. Or simply when a base dissolves in water, always it produces not only the sodium hydroxide or potassium hydroxide, any base produce OH minus ions. Thus a base is a substance which dissolves in water to produce OH minus ions in solution. That means it is the presence of OH minus ions which impacts basic nature to the substance. How the H plus ions impacts the acidic nature to the substance, in the same manner these OH minus ions impact this basic nature to the substance. If the concentration of that OH minus ions are high, then that is strong. If the concentration of OH minus ions are low, that is weak. That means while diluting bases, how can we dilute that bases? Simply water is taken and what is added? Base is added. That means this concentration decreases. That means the number of OH minus ions in unit volume of that solution decreases. If the number of OH minus ions in OH minus ions in unit volume of the solution decreases, means its concentration decreases. Why the number of OH minus ions are decreased? Means its concentration decreases, then it is diluted solution. If more number of OH minus ions are present in unit volume of solution, then that is concentrated solution, concentrated base. If less number of OH minus ions are present in unit volume of solution, then it is dilute solution. Like that we define this concentrated bases and concentrated dilute bases, concentrated bases and dilute bases. Again, these bases are classified into two types, that are strong bases and weak bases. On what factor does these bases classify? Does the base classify into strong bases and weak bases? Based on ionization. Already we have learned about this ionization. What is ionization? Simply the splitting of a molecule into its respective ions is called as ionization. When a base is added to water, it splits into its which ions? It splits into positive ions called as metal part and OH minus ions. Okay, in that solution, if how many molecules are present in the unit volume of that solution, if all the molecules are ionized, that means it is completely ionized, then it is 100%. Then if the ionization extent is 100% means it produces a large number of hydroxide ions. If it produces a large number of hydroxide ions, then it is a strong base or strong alkali. Okay, for example, let us observe in this diagram. What we observed in this diagram, In this, simply we made an electrolytic cell or voltmeter. In the first case, in the voltmeter, which solution is taken? Alcohol solution, ethyl alcohol solution. And in the second case, sodium hydroxide solution. Third case, ammonium hydroxide solution. Is the bulb glows in all the three cases? No. In the first case, that means in the case of ethyl alcohol solution, the bulb didn't glow. Even the circuit is made like this and the power is supplied, but the bulb didn't glow. But in the second case, that means sodium hydroxide solution, the bulb glows brightly. What about the bulb in the third case? The bulb glows, but its intensity is low. That means the bulb is in low light condition. In the first case, why the bulb doesn't glow? That means in that case, these ethyl alcohol molecules in the water present, what is added? Ethyl alcohol is added. These ethyl alcohol molecules are not ionized, that are not split into its respective ions, that remains as molecules. Observe in the diagram, that are closely packed and that are not splitted, like in the second and third cases. That means these molecules remain same as molecules. That means it's that are not ionized. If they are not ionized, what are the charge carriers that are ions are not present? Due to the absence of the charge carriers, the bulb didn't glow. But in the second case, sodium hydroxide solution is taken. That sodium hydroxide solution splits into its respective ions. NaOH splits into Na plus ions and OH minus ions. How many sodium hydroxide molecules are present in that solution? Totally all that molecules are ionized. Observed in this diagram. For example, if 3 molecules are there, that 3 molecules splits into its ions. If 30 are there, that 30 splits into ions. How many are present? All that are splitted into its respective ions. That means ionization extent is 100%. That means more number of hydroxide ions, OH minus ions are present. More number of charge carriers. That's why the bulb glows brightly. Okay, that's why it is a strong acid. Okay, then what about this let us observe then what is strong base here. We are discussing about bases, not acid. Then what is about a strong base which is completely ionized? That means how many molecules are present, all that splits into its respective ions. It is a base, that's why it produces OH minus ions. If it is completely ionized, means it produces large number of OH minus ions. That's why it is a strong base or strong alkali. That's why the bulb glows with very high intensity, brightly. Next, what is happening in the third case? Let us observe in the third diagram. Which solution it is? Ammonium hydroxide solution. Simply in this ammonium hydroxide solution, for example, if 3 molecules are there, only one is splitted into NH4 plus ions and OH minus ions. Out of 3, only one is splitted. That means if 30 are there, all the 30 are not splitted. If 300, all the 300 are not splitted. That means its ionization extent is less than 100%. If the ionization extent is less than 100%, then that are called as weak bases. These weak bases are also called as weak electrolytes. That's why this ammonium hydroxide is a weak base. That's why the bulb glows dully. That means with low intensity, with dim light. Okay. That means then how do you define these weak bases? A base which is partially ionized. That means its ionization extent is less than 100%. It produces small amount of hydroxide ions. Which produces small amount of hydroxide ions, that is called as a weak base. Okay, we use these weak bases in our daily life, just antacids, like antacids. Okay, that means to neutralize. Whenever we suffering from a problem of acidity, what we use? Antacid tablets. Generally, what is present in that antacid tablet? Is it a strong base? No. If it is a strong base, it neutralizes the acid. Again, the basic nature of the digestive system increases. It is hazardous. Then what we use to neutralize the acidic nature? Simply weak base, mild non-corrosive base. Ammonium hydroxide, NH4OH, what we call as milk of magnesia. Its common name is milk of magnesia. it is used as weak base to neutralize this acidic nature. That means whenever we suffer a problem of indigestion, that means what we call as acidity. Okay, these are about strong bases and weak bases. The strong bases are also called as strong electrolytes. Sodium hydroxide, potassium hydroxide. Okay, these are the examples of strong bases. Next, weak bases. Weak bases are also called as weak electrolytes. Ammonium hydroxide, magnesium hydroxide. These are the examples of weak bases or weak electrolytes. Then what about this ethyl alcohol? It is non-electrolyte. Like that we classify. Then now about properties of bases. Already we have learnt about the properties of bases. Just again revise the properties of bases. First about physical properties. What are the physical properties of these bases? If we take bases, all these bases are better in taste. Okay, just try to taste this, what is that, washing soda or cooking soda, that are better in taste. Okay, not only this, all the metal oxides, metal carbonates, metal bicarbonates, metal hydroxides, all these are better in taste. Not only these are better in taste, these are soapy to touch. Whenever we touch, we feel soapy. That's why all these are bases. That's why bases are the substances which are better in taste and soapy to touch. And to test whether a substance is in basic nature or not, we have some indicators in our chemical lab also. What are that indicators? Litmus papers, methyl orange, phenolphthalein. These are the indicator to test whether it is an acid or base. If it is base, what about the color change with litmus paper? If it is base, that red litmus paper is changed into blue. Just collect a substance, any substance what we use in our daily life or from our chemical lab, and take small amount of the test tube in a china dish. Add small amount of water to it. That means aqueous solution of the substance what we take, that is prepared. Take a red litmus paper and dip the red litmus paper in this solution. If that red litmus paper is changed into blue, then it is base. If the red litmus paper remains as red litmus paper, then what happens? It may be an acid or neutral. If the red litmus paper is changed into blue, then it is base. If red litmus remains as red, then it is an acid or neutral. That's why bases turn red litmus to blue, but acids turn blue litmus to red. For this we have an int. What is that? Able red. Acids change blue to red. Then what about bases? Bases change red litmus to blue. Next, other indicators, methyl orange and phenolphthalein. This bases change methyl orange into yellow. Methyl orange means it is orange color indicator. When 2 or 3 drops of methyl orange is added to base, if it turns into yellow. Or if we add 2 or 3 drops of methyl orange into a substance, if it turns into yellow, then it is a base. Like that we decide. Then about phenolphthalein indicator. What is this phenolphthalein indicator? This phenolphthalein indicator is a colorless solution. Bases change this phenolphthalein indicator into pink. And already we know the bases conduct electricity. That's why the bases are also called as electrolytes. These are the main physical properties of bases. Okay, in the next class, we will learn about the chemical properties of bases. Thank you.